Hey everybody, this quick little PowerPoint video covers physical and chemical changes in matter. This is a real important thing in chemistry because as we do a lot of our experiments this year, as long as COVID doesn't keep us from doing them, we've got to be able to recognize when something is just a physical change. In other words, we're making a mixture, or when we're actually getting chemical bonding, which is a chemical change occurring. So what we're going to try to do is spend a couple minutes talking about physical and chemical changes in matter. Once we finish this, then guess what? We've got a lab procedure we're going to try to get done today. All right, so physical changes alter simply the physical properties of a substance. You know, if it's a 8.5 by 11 sheet of paper and you cut it in half, guess what? It is no longer an 8.5 by 11 sheet of paper, but it's still a piece of paper. You can still write on it. It's just smaller. So what I'd like for you to do when we finish this page is to go ahead and pause the video and take a few minutes, talk with somebody else around you. If you're in the classroom, let's talk with somebody. If you're a virtual student, then go ahead and do a chat with somebody who you're virtually learning with, and identify 5 examples of what you would consider to be physical changes that can occur. At the same time, I'm going to have you take those 5 minutes and identify a few of the examples of a chemical change that can occur. Chemical changes are reactions that alter the identity or composition of the substances involved. So let's go ahead and take a few seconds. Come on back when you're ready, and then we can move on. Hi, welcome back. So what did you guys come up with for physical changes? I had the conversation with somebody a long time ago, and this is what we came up with. This isn't the only thing that you could write, but let's go ahead and continue the process and say physical changes. Ice, when it melts, is a physical change. Phase changes, melting, boiling, freezing, thawing, are all considered physical changes because all it's doing is changing physical properties. When gasoline evaporates into vapor, you cut something up, you sand it, you squeeze it, you blend it, you bend it, sugar dissolving. These are all physical changes. It's still the same material, but you've just changed something about one of its physical properties, or maybe more than that. All right, what did you come up with regard to chemical changes? Anything that changes who you're talking about. When hydrogen burns in the air, it works with oxygen and forms water. You don't have hydrogen left and you don't have oxygen left. You actually have a new compound. Iron reacts with oxygen and water to form this new substance called rust. Fossil fuels are going to burn. Thank goodness for that for our cars. As we continue to move more towards hybrid cars, then we're going to be talking about other types of fuel sources. All right, so this is the most important of the slides on this particular PowerPoint. There are things that you need to look for evidence of a chemical reaction. Some of these things are what you're going to be looking for today in the lab. The idea is you're going to look for the unexpected. For example, unexpected heat, cold, and light. My goodness, if you heated something up on a hot plate, it's going to be hot. That doesn't mean it's a chemical change. If something was room temperature, however, and all of a sudden it's burning hot just because you added this powder to it, that's probably an indication, evidence of a chemical reaction. Likewise, if something gets cold, or if something gets very light and bright. Unexpected. Unexpected gases being produced, which is going to create bubbles. If you look over to the right, you'll see the tall graduated cylinder, and it looks like there's steam coming out. There's our heat, and it's also got bubbles coming up from the bottom. So gases being produced, and you generally can tell this by fizzing and bubbling. All right, a solid precipitate forms. Now we all know what precipitation is. It's rain. It's falling down. Well, a solid precipitate is what you see in the upper right hand corner. You have all those test tubes, and those test tubes have got a solid forming at the bottom or in the middle of it that had not been there before. Previously it was just two liquids, and then all of a sudden you have this material forming. And so that would be an evidence of a chemical reaction. Color changes. Again, they can't be expected ones. I say this one every year. I'm sorry, but if I put red and blue together, I better daggone have purple. But if I take white and red together and all of a sudden I get green, I go, wait a second. Where did that come from? It's unexpected color change. And then smells. All you got to do is light a match. And we're going to do that in a little while. We're going to light a match and we're going to see whether it's a chemical or a physical change. And then the last one is, and this is kind of a harder one to do, but you know, if you leave something alone after it looks like it's changed and it goes back to what it was before, it means it probably was not a chemical change. But if it doesn't go back to what it was before, then it's evidence of, it's not guaranteed, guys. It's not guaranteed that it's evidence of a chemical reaction, because all you got to do is think about Humpty Dumpty. Okay? If you think about Humpty Dumpty, who sat on a wall and had a great fall, and all the king's horses and all the king's men can't put Humpty together again. I'm sorry, you leave Humpty down at the bottom of the brick wall, he's not going to be put back together, but this is not a chemical reaction. That was 100% physical change. Alright guys, so there's this video I really wanted you to be able to see. Unfortunately, it's not playing. I've left you the URL down at the bottom. It's a cute 3-minute video. There's nothing much to it about rusting of iron. What you need to understand is that every chemical reaction has a chemical change that can be identified in a chemical equation. And that's what this was about. It's a cute little video. No need for us to waste our time with it since it's not going to work. But it's about a 3-minute and 32-second video. Let's go ahead and move on. There we go. It's wanting to try again. We're going to stop it because it's just not going to work, and we're going to go ahead and get to the next slide. Alright, in a nutshell, what we understand is that physical changes do not ever change the identity of a substance, whereas chemical changes always are going to end up with some new substance formed in a reaction. In the case of iron rust, you start out with iron and you add to it oxygen and you end up with iron 3 oxide, and what you see is this unusual, unexpected change in color of the iron nails in this particular case. Alright, we need to remember that physical changes, or phase changes, I keep saying that wrong, phase changes are physical changes. Most of them occur simply because we heated or cooled down a state of a material that was in one state of matter and it changed it to the other. Sometimes we cannot just use temperature, but sometimes pressure is involved with the change also. In fact, it always is. It's just a matter of whether or not we notice it. But this sublimation occurs when both pressure and temperature are at the right conditions. Most of us haven't seen it. We've experienced it, but we're hopefully going to see it in our lab today. So anyway, we're going to stop there. Hopefully this time I won't have to redo it again. And you've got some questions to answer, and then we're going to move on to the lab. All right, thank you.